My name is Caroline Bonner. I'm a Senior Research Scientist at Institut Pasteur de Lille, affiliated with INSERM Unit 1190, Translational Research for Diabetes, directed by Professor Francois Batou. I obtained an Eyesight Principal Investigator Award from Eyesight in collaboration with Dr. Adrian Liston from KU Leuven. This project is a Code to Tell, an award to supervise an international PhD student. Together we will explore the role of HNF1 alpha in the regulation of glucose homeostasis with a particular emphasis on HNF1 alpha modi. What is HNF1 alpha? HNF1 alpha is a transcription factor which is important for the regulation of key metabolic genes in their target tissues. How does it work? It makes sure that these genes are expressed in the right amount and in the right time. HNF1 alpha allows insulin to be secreted normally in childhood, but as these children age, they develop insulin secretory defects, and the mechanisms are still not known despite 25 years of research. So why is HNF1 alpha important in these children? Well, it's very important that the children get diagnosed because they are living with hyperglycemia for more than 20 years, and if they don't get the proper treatment, then they will develop overt diabetes with devastating secondary complications such as cardiovascular disease, retinopathy, stroke, which can even lead to leg amputation. So the first line of treatment for these patients is sulfonylureas. So how do they act? They bypass the glucose signaling pathway and they act directly on potassium channels to stimulate insulin secretion. However, these children are given these drugs very early in life. However, chronic treatment with these drugs can cause beta cell exhaustion, and these patients are also prone to developing hypoglycemia. Therefore, new therapeutic strategies are needed. This PhD thesis has three specific aims. The first aim is to map HNF1 alpha across a series of pancreatic tissue isolated from pancreatic donors across all ages, from young adulthood to elderhood. Using HNF1 alpha mutant mice and their littermate controls and cellular models of MODY, we will aim to determine the effect of HNF1 alpha deficiency in glucose homeostasis and pancreatic hormone secretion. Using these models, we will also compare the efficacy of the gold standard sulfonylureas to the new anti-diabetic drugs, the GLP-1 receptor agonists, to determine how these drugs are efficient in regulating pancreatic hormone secretion. In Dr. Adrian Liston's lab, we will generate islet-specific HNF1 alpha knockout mice to determine the effect of this mutant during embryogenesis and postnatally, and what is the consequence of this mutant on pancreatic hormone secretion.